So for starting out, the robot uses 10 motors, 4 393 motors, and 6 269 motors. That is the maximum amount of motor power that you are allowed to put on a robot legally. That's equivalent to roughly equivalent to 12.4 original Vex motors. That power has been very key with all my designs. The first thing I think about is I have so much power to use on it. What ratio would I be able to run and get it to work without overheating, without trying to pull too much power from the motors, and still make it as fast as possible? So I started building way back in August. My initial design was a little bit different, but I knew that I wanted a 6-wheel drivetrain. I knew that I wanted it as fast as possible, and I knew that I wanted a high end. Ever since Karthik at the Worlds last year said, now that'll separate the good robots from the best robots, or the good robots from the great robots. On the latter, I was like, oh, I got it, high end. But I've always had the double extending vertical lift. The reason that it double extends, I've only seen a couple double extending vertical lifts here, and not instead of single extending, as you can see it extends in 2 places. The reason that it has to do that is because the high hang, you need to gain at least 19 inches. Your robot has to be off foam 18 inches, and you always have to have a little bit of room. So you have to be able to gain 19 inches, and there's no way to do that, or a very limited number of ways to do that with only a single extending tier inside the sizing box. So I went with this double extending tier. Instead of the more popular rack and pinion gears, I decided to go with high strength Sprocket chains. This chain interlaces through the different tiers and is attached to this top one. The middle tier is independent. The reason that I did that was I wanted to be as strong as possible, and at the same time I wanted to be able to configure my gear ratios based on how much power I could use at that time. I went through a lot of different designs and a lot of different versions of this robot. So I've had anywhere from 2 393 motors to, this is the most I've ever had, 6 269 motors on the lift mechanism. At one time I had an H drive, which allowed it to strafe left and right. But that was at my last competition. I decided that I was better off consolidating my motors into just 2 main applications. So we have the vertical lift and the drivetrain. My drive wheels are 160 RPM on 4-inch tires, which, given that motors never quite run at their full speed, is about 32 inches per second. The entire robot is aluminum. Having said that, it also weighs 19.5 pounds, which is really heavy. The reason it's so heavy is because I have 2 batteries. They're almost a pound each, and 2 pneumatic tanks. I also had to build my base, and the whole robot pretty hefty if I wanted a high hang. It has to be strong, it has to be able to take a beating. It's also very important to keep my center of gravity very low to the ground. When you have something that's this high off the ground, I could tip this over right now if I didn't even know how to drive it. So the more weight you have, the lower to the ground it is, the harder it is to tip something over. To pick up rings, I have these pneumatic grippers. You know, a popular gripper design. There's been other gripper robots. Well, it raises up and I can lower it onto a goal to score. I chose to make everything subroutines because I have only 1 driver versus most people have 2. And when you have a robot that is not exactly simple, it's easier if the robot controls itself, so to speak. So when I go up to a stack, if I hit this button right here, it picks up the stack and automatically goes to the height of a movable weighted base. As there are 5 movable weighted bases on the field and 4 wall goals, it's safe to assume that I'm probably going to score it on a movable weighted base. I drive up to the base and I hit the same button again. Now it's scored. And I back it up and I hit the same button again, and it's back down to the ground. When you saw me doing the Robot Skills Challenge, 90% of the time I was using this button, and I just kept on clicking it. The robot is set up so that if there is no tube there at all and I try and hit this button, it knows that, and it won't lift. I also have subroutines for the wall goals. If I want to score a wall goal, while it's lifting up, I hit this button right here, and it goes to the height of a wall goal. When it's at the height of a wall goal, it knows that this button is set up to score wall goals now, which means that when it goes to lower 1 tube, it doesn't go quite so far. It only goes like that. I have a piecewise function / proportional loop, control loop that controls that lift mechanism. So I have encoder, a quadratic encoder here and a limit switch there. So I know exactly where it is, and the robot knows based on my input where I want it. For high hanging, I have 2 double-acting pneumatic pistons in the back, which tilt this forward and backwards like so. And then I just back up to the ladder and lift it up like so. And then once I have it in position, if I back the robot up and at the same time lower the lift, the robot high hangs. Once it is high hanging, it locks itself in position mechanically so that after the end of a match, when they cut power to our robots, it'll still stay up there. If I didn't have these mechanical locks right here, at the end of the match, the robot would probably slide down, and it would look something like this by the end of the match, in which case I wouldn't get any points at all. I can also get off the ladder if need be. I haven't really used it today, but like so. So that's how it works. I have 2 pneumatic tanks, 4 pneumatic pistons, 2 batteries because I use a power expander, and 10 motors. I'm also using virtually every port on the Cortex controller for sensors. I have 2 ultrasonics, 2 encoders on the drivetrain, 1 encoder on the lift mechanism, as well as 3 line sensors and some autometers that I use to select between different autonomous codes. I found that if you run the same autonomous code every time, people get smart and they program their robots to block you once you get to the finals. With this setup, I have a different code that I can run in case that happens. Or in case one code's not working quite right that given day, I'll just move on to the next one. Are there any questions?
So let me point out a couple quick things to you guys. He said a lot of things real fast there. Vex is new to this area, right? 18 months ago, we had like 13 teams in this area, guys. We're now over 350, okay? But we're still very new at this. So let me point out a couple things. Okay, set it up where... He said that it knows when there's a ring in here. How does it know that? Well, there's these little switches in here. When the ring bumps into this switch, it knows there's a ring there. If the switch doesn't get closed, it knows there's not a ring, it knows not to grab. You see these little red things on the side. These are the ultrasonic sensors. It sends out a little ultrasonic sound pulse, times for it to come back. It can tell distance. So he can tell how far away he is from a wall on both sides. He has encoders. There's a little red device buried in here, right in here, and it counts rotations. So he knows exactly how many rotations he has on that motor and exactly how high that thing went and exactly how far his wheels have moved. Do you have a line sensor on the bottom?
Oh, yeah.
On the bottom, you'll see 3 little red boxes right here. These things are used to detect the white lines. So that robot can actually follow a white line all the way around the field when it's programmed to do so. On the back, he's got an LCD display. It's something that's new with Vex. You can actually send messages to this and dial in different routines, different programs, reconfigure your robot on the fly using that display. So he's using every piece of technology that Vex offers here. It's a marvelous opportunity for you guys to be able to see that. Thank you very much for taking the time, though. We appreciate it. Let's keep finals, guys.